Like chapter 3, we start off with these things called exponents, and then we go into algebra tiles, and then all of a sudden we jump back into solving really difficult equations. And so we're going to start here with our exponents. And the exponents are going to be the main part, because the exponents are what you're going to take your short cycle on. It's the standard that we're checking in on. The other stuff is important, but the other stuff doesn't show up again until chapter 8. So we're really laying the ground for chapter 8, which is like, well, that seems so far away, but it's really not, and we need to practice it now. So this first part is going to be the most important part in chapter 3 in terms of grades. The second part will be important later, okay? So an exponent. When do we see an exponent? When I'm doing what? Over and over and over again. Yeah, multiplication. So this is when I'm doing repeated multiplication. Now, you don't have to write this next part, but I just want to show you the difference. Somewhere like in 3rd grade, you guys learned the shorthand to this. That's a lot of 2's. I don't want to write 2 plus 2 plus 2 plus 2 anymore. We're going to say that's 2 5 times, okay? But that's when you were learning your multiplication. But right here is where we are in algebra. You are now multiplying over and over and over again. And so that's where that exponent is. Notice we still have the 2 and the 5, but it looks very different. 2 to the 5th is very different than 2 times 5. Repeated addition is something different than repeated multiplication. All right. Now, you also, because this is algebra, of course we're going to have things in letter form. So if we have this exponent b to the a, the b stands for the base. And the base can be a number, the base can be a letter, and as you're going to see later on in the chapter, it can actually be a whole algebraic expression. So it can be like almost like an equation. So the base can be a lot of different things. The a stands for that exponent. Now the exponent can also be a letter or a number. For right now, it's always going to be a number. But when we get into chapter 5, you're going to see, ooh, it can also be a letter. What? It can't. The number one thing about exponents is what happens if you get confused, okay? How are you going to solve that problem? And our number one goal for you, like we talked about strategies with using color and things like that, our number one goal when we look at exponents is to expand. So for the first questions, I don't want you to do anything but expand. So y to the 7th means what? Well, it means I have y times y times y times y times y. 1, 2, 3, 4, 5, 6, 7. That's what it means. I want you to understand the meaning before we just jump into, okay, solve all these guys. That's what I do not want you to do. We'll give plenty of time for solving, okay? But we don't always have time when we look at just what is this. Okay, let's look at number 2. Because now you not only have to figure out the variables, but now we're throwing numbers in there as well. So this means I have 4 times 5 of these x's times 2 y's. Now, and I don't know why, but something always happens. I say today is like the fluffy ice cream cloud rainbows day of exponents. It's the nice day of exponents. On Monday, things get a little bit more complicated. And so one of the things I want to make sure is these problems are going to get a lot more complicated. Do you see any addition sign in there? So when they get complicated, you guys are going to be at the whiteboard, you're going to be doing these problems. All of a sudden, students will just start throwing in these addition signs. Remember, exponents are always about multiplying. Don't throw in addition signs or, adding or subtracting all of a sudden. It's always multiplying. Well, this is interesting. This is known as a power to a power. So I have this 3 and this 2 raised right here, but what this means, this outside power tells me I have 2 of what's ever on the inside. So this means I have 2 of these things called x cubed. Doesn't matter what's on the inside, I've got 2 of them, okay? Now I can expand from there because I know x cubed is x times x times x. Then I have another 3x. That's what it looks like when it's expanded out. Okay, that next one. You're going to see a whole bunch of parentheses. You're going to see powers. And you have to understand what's on the inside and what's on the outside. So let's look at the 5. Is the 5 on the inside or the outside? Outside. That means that this 3 has nothing to do with the 5. This 3 only applies to what is on the inside of those. So again, this means I have 3 of those things called 2m. But I also have a 5. So I have 5 times 2m times 2m times 2m. The other thing you're going to see me do is to organize. One of the hardest things about exponents is you're going to have all of these numbers and letters everywhere organized. So what I tend to do is I put my numbers first. Then I'll put all of my letters, all the same type of letters, together. And again, this means the same thing. They're equal. I just organized it so I can see it better. Okay? You are more than welcome to just organize it. Sometimes people can skip that step, but I'm one who I would miss a 2 or would forget there's a 5. Okay? All right, number 6. Number 6 is my favorite type of question because this is where things are going to get complicated on Monday. But for right now, these are nice problems, okay? But they lead to really interesting discussions about exponents. So this one right here, we have a fraction. It's okay, just leave it as a fraction. The numerator is x cubed, which means x times x times x, and my denominator is x. Okay. So remember, guys, this whole section, these first 6 problems, are nothing more than do you understand what exponents mean? Because then when we start simplifying and things get complicated, you are going to be able to say, oh, I remember what this means. And when you ask me, if you say, I don't understand what this means, I'm going to say, expand it out. That's going to be always what I tell you, expand it out. You'll say, I don't understand. So I'll say, expand it out. Keep this as your, I know what all of these exponents mean. Okay. But of course, mathematicians aren't going to allow us to write our answers like this. That's way too much writing. So the questions that you're going to be getting are called simplification. Notice, simplifying is different than the word solving. To simplify means to make it as nice and neat and concise as possible. So how do we do that? Well, let's take a look at number 1. Number 1 says I have x squared, which is x times x, times x cubed, which is x times x times x. So I'm really asking, when I'm simplifying, I'm asking how many x's do I have? How many y's? How many 2's? I'm just asking how much do I have? And this one, I have x to the 5th power. I have x times x times x times x. This is the answer that they're looking for, okay? All right. Knowing that, I want you guys to try number 2. See if you can figure out what number 2 is. If you're in doubt, expand it out. If you are starting to see patterns, if you're starting to see like maybe some shortcuts, feel free to use them if you get them correct, okay? So keep going. You have x to the 4th, 1, 2, 3, 4. You have x to the 5th, 1, 2, 3, 4. Okay. So that you have more than 11. I will say you have more than 11. So you are very close to number 4. Okay? And close to number 6. Think about those. What do you get? Nice. Very good, you guys. Yes, very good. You get x to the 12th. If you expand that out, you get 4 x's plus another 5 plus another 3 for a total of 12. Okay, so let's talk about this one. Okay, there's that power to a power. I now have 5 of these things called x squared. So I have x squared times x squared times x squared times x squared times another one. Now at this point, if you need to, go ahead and say that's x times x, x times x, or if you see it, you have 2 here, 4, 6, 8, 10. You have 10 of those x's. So this one's going to be x to the 10. Okay, knowing that, try number 4. Okay, try number 4. See if you can figure out. Think about expanding if you're not sure. You are very close. So, you expand that. Now we want you to okay, you have it exact. Now, be careful on this one. Yeah, you only have 4 of these things, okay? Now, this brings up a really good point. This 2, and you don't need to write this part down, but I want to make sure that this part is clear. This x cubed, that 3, only belongs to the x. So what this means, 2x cubed means I have 2 times x times x times x. That 3 just has nothing to do with the 2. If it looked like this, then you would have 2x times 2x times 2x. So just be aware of that, okay? But let's talk about 4, because here are all the answers that I saw for number 4. I saw 2x to the 12th, I saw 8x to the 12th, and I saw 4x to the 12th. Safe to say that the x to the 12th is correct, but I'll tell you it's not none of those. So let's expand it out. Remember, this means I have 4 of the things inside the parentheses. So I have 4 of these. Because it's 2x cubed that's inside the parentheses. So I have 4 of them. Now, at this point, some of you are like, oh, I've got a 2. But I'm going to rearrange the pieces so you can see them. So I'm just going to put all of my numbers together. And then I'm going to put all of the x's together. So notice you all saw right away that this is 3, 6, 9, 12. Oh, that's where those 12 x's come from. But what about that number? Here's what will always happen. Students will see the x, but they'll forget about the numbers. So what's 2 times 2 times 2 times 2? 16, and that's the answer for this guy. Be aware, this does not mean 2 times 4. That means I have 2 times 2 times 2 times 2. I have that 4 times, okay? So be really careful with those numbers. It's the one that gets them every time, and when we do multiple choice, all of these will be choices. So it's easy to get fooled there. Okay, we're going to look at these last two, and then I'm going to let you guys just try a bunch. Again, my favorite type of problems. I have x to the 6th divided by x squared. So let's just write it out. X to the 6th means this. Okay, x squared means that. Now, before I jump into what this one is, we have to do a little dividing lesson. What is 5 divided by 5? 1. What is 1,000 divided by 1,000? What is pi divided by pi? What is smiley face divided by smiley face? So what is this? What's x divided by x? Anything, and I mean anything, smiley face divided by smiley face, anything divided by itself is 1. And so when you get to these type of problems, what you're looking for are the ones. Because we get to cross them off because they're just 1. So let's take a look at this. Oh, look, here we have x divided by x. That's 1. There's another x divided by x. That is also 1. So what do I have left over? I have 4 of those x's. And where do they live? Do they live in the numerator or the denominator? So I have x to the 4th. Now, if we wanted to get technical about this, we could say it's over 1 because in the denominator I have a 1 times a 1, but really we just like x to the 4th.
What if it was in the
That's a good question. That's what we're going to get to, okay? We will get to that. Then it just stays in the denominator, okay? All right, knowing what you know, try number 6. See if you can find number 6. Okay, I want to see what are we doing. Very sure, stand it out. Now you're going to see me write it a little differently, but you are correct. Now this I will say, these type of questions in 6 are where things get really confusing. Okay? Because we are now looking at numbers and exponents and fractions. So let's expand this one out. Remember, this 5 only belongs to that 6, or only belongs to the x. That's a good question. Let me see if we can see this. So 6x to the 5th really means I have 6 times 5 x's. There's an exponent on the 6. What is it? We don't write it. Yeah, it's just 1, okay? But that 6 is really, there's just one of them. There are 5 x's, okay? That's how you interpret that. All right, so let's write this one out. Now you're gonna see me write those 6 and the 12 in a different way, okay? Don't panic, I'll explain why in just a second. Times x, x, 3, 4, 5. In the denominator, I have 12, which I'm going to call 2 times 6, times x, times x, times x. Okay, why do you think I chose to write my 6 and my 12 as factors? Because I can already see the answer. So here's what I see. Students will get really excited because they'll say, oh, I see a 12 and a 6. Yes, it's a 2. And then I only have 2 x's. Boom. answer's done, because they see the 12 and the 6. But be careful. Be careful about where that 2 lives. So I know that 6 is 1 times 6. I also know that it's 2 times 3, but I'm going to leave it as 1 times 6. I know that 12 is 2 times 6. Now, Justin said, oh, I know why you wrote it that way, because what happens to my 6s? They go away. That's why I chose to write it that way. This is how you reduce fractions, by the way. So if you struggle with reducing fractions, this is how you do it. So the 6 divided by 6 goes to 1. X divided by x goes to 1. There's another x divided by x. Oh, and we have another one. So once you get it down to here, the game that you're playing is, what do I have left over? So what's on the top? Yeah, and if you want to put the 1 times, you can, because it's going to be 1 times x to the squared. But what's in the denominator? What's left? 2. There it is, okay? That is the challenge. So be careful. There is a 2, but it lives in the denominator. And I promise you, if you expand all of these, you will not get them wrong, okay? All right, turn your page over. What you're going to do is you're going to do all 7 problems. Try them on your own. I'm going to come around and help, but try them. Okay,